In today's video, we are going to solve another problem related to subsets, which is based on backtracking concept. This problem is very similar to subset 1 problem, in which the given numbers contains only unique elements and we need to generate all possible subsets. But in this problem, there are also some duplicate entries will be present in the given nums array. So we need to generate all the possible subsets and return it as an output. So this is the problem statement, and if you go through the problem constraint, there will be elements from -10 to 10 and the length of the array will be from 1 to 10. So keeping these things in mind, and I suggest you to go through that previous subset problem in which where we will generate all possible subsets for a given nums array where there will be no duplicate entries in the given array. If you understand that problem, solving this problem becomes very easy. So I suggest you to go through that video first and then come back to this video. I have given link in the description. Please feel free to check out that video as well. So let's start discussing the approach, and later we will code this solution. Let's discuss approach for the same problem. For this first example, the first question example is given numbers are 1, 2 and 2. We need to generate all the possible subsets, and our output should not contain any duplicate subsets. So in order to do this, what we can do is we can follow this approach. First we will sort this array. First thing that we are going to do is we will sort the array, and once we sort the array, it becomes very easy for us to skip any duplicates, and then we will start generating subsets. So the reason why we are sorting is in the constraint also they have mentioned there will be only length will vary from 1 to 10, and we can easily sort the array, and then we will start generating the subsets because we need to skip duplicates while generating the subsets. What we are going to do is initially we will start with an empty array, and this will also be a subset, and after that we need to select the first element. So initially our starting index, we will keep on getting this starting index as an argument to our function, and here we need to choose the starting element irrespective of whether it's a duplicate or not. So for starting index we are going to choose that element because I is 0, 1 is present at index 0. And after that, and when we come here from 1 to 2, at this point we have to choose the first 2 which is present here, that is 1 and 2. So but we don't go for this path where we will choose this second 2. What I am talking is here we have chosen 1, and if we start choosing these two things we will get this, and we don't choose this element, this 2, because this generates a duplicate subset. So how can we skip this entry? We can just compare before pushing to our current combination. We can check whether this is already present, whether this element is equal to this thing. So if that is a duplicate, then we don't go for this path. And here after we come here 1, 2, we will choose 1, 2, 2. What I said earlier is we don't create a duplicate here as 1, 2. This is what we were discussing, but here we are choosing 2 because this will be the starting index. Initially index will be 0, starting index, and here I becomes, here I is 0, and here I becomes 1, and here I becomes 2. So wherever starting index is present, that element we are going to choose, but otherwise we will check whether it is a duplicate or not. So similarly, if I write all the function calls, what we get here is we get a 2 here, and after that 2 you're going to get a 2 2. So because here it will be a starting index, so here we will get starting index as 1, and here we will get starting index as 2. So this is what we are going to do, and these are all the subsets of the given set which consists some duplicate entries. Only thing is we need to initially sort the array in order to skip the duplicates. I hope you understood this approach. If you can write code with some print statements in which you will print all the function calls, it becomes very easy to understand. Keeping these things in mind, let us implement the same solution using C++ programming language. Let's implement the same solution that we have discussed here. So initially we have to sort the array in order it becomes very easy to skip the duplicates. So we are going to use inbuilt sort function, where we will pass arguments as from begin to end. We need to sort the whole nums array, and once we sort this, then we are going to call generate subsets, and for this function we are going to pass a start index and a current nums, and then we are going to pass the actual nums. So we need to implement this function, and before that we need to declare another variable which is going to store all possible combinations. So this will be a 2D array, 2D vector, and for current nums it will be initially empty. And after that generate subsets function will update these combinations, and finally we are going to return here. We still need to implement generate subsets function. So what we are going to get here as arguments, we will get a start index and current nums, and we are going to take it as a reference in order to make our function a little bit faster. I am going to expand this window a little bit so that it becomes easy for us to see the code. And whenever we come here, we need to push the current combination before doing anything. So combinations dot pushback current nums, and after that we are going to check whether our start index is greater than or equal to nums.size. If that is the case, we will not do anything, we will just return, and otherwise we will start a for loop for int I equals start index and I less than nums.size. Then we are going to start with this for loop. In this for loop, if we just have to choose the starting index, otherwise we have to check for duplicates and skip it. So we will check if we are going to check for duplicates. If our I not equal to start index and nums of I equals to nums of I minus 1. Since the array is sorted, If these two are equal, then it means a duplicate. For the first element, we are not going to check for the duplicate because we need these elements. If that is the case, we are going to skip. Otherwise, we will push our elements to current nums. Current nums dot pushback of nums of I, and then we are going to call this function recursively. Generate combinations. Start index will be I plus 1. I plus 1 and our current nums and nums. And after that, when we return from the recursion, we need to pop whatever the element that we have added to our current nums. So we are going to pop back. This is the solution that we have discussed, and implementation is very similar to what we have discussed in the previous section. So let us submit this solution and check whether it passes the initial test cases or not. Okay, we are getting some typo here. Okay, generate. Actually, it should be generate subsets. I don't know why I wrote generate subsets. Let us run this solution and check. Okay, we missed a semicolon here. Okay, it is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.